Okay, so over here, this area, what are the formulas you know to find the area of a triangle? What? Half times base times height. Okay, excellent. Can we use that? Can we use half times base times height for part B? Morning. Equals to half times base times, when you say height, you meant the perpendicular height, right? So where is the base for this, Sophia? AB, is it? Where's the base? AB, so 22. Then where's the perpendicular height? Which one? Is it? I have to draw it myself. Like that, is it? Then am I going to try to find that line? Very troublesome lah. There is another formula we can use. Yeah, half AB sine C. So this is, we realize that this is not too useful lah, okay? We use instead half AB sine C. When I say AB, I mean two sides, okay? Out of this triangle, how many sides are given to you? You're given two sides, you calculated the third side. And the AD is 20.7. Okay, so now we need to make a choice. Area of triangle is half AB sine C according to the formula given to us. How do we decide what is A, what is B, what is C? Yeah, the small a, small b, and the capital C. One of it is an angle, isn't it? C is the angle. How many angles do you have here? Only one. So it's going to be half times something sine of 60 degrees. So what are the something that you need to fill in? Anissa, what do you think? 22 and 19. Okay. Must I choose 22 and 19? Can I choose something else? I cannot. Because for this formula to be used, the angle must be an included angle. This is an included angle. What is an included angle again? The included angle is the angle in between the two sides. So you look at this triangle over here. What are the two sides with where, okay, this angle over here, 60 degrees, it is between two sides. And the two sides are 22 and 19. Okay, so half times 22 times 19 times sine 60 will give me the area of the triangle. If I choose to take half times 22 times 27, then I need to multiply this by sine this angle. Let's call it theta. To get the area of the triangle. I cannot use half 22 times 27 times sine 60 because then 60 is not an included angle. Any questions? No? Okay, so based on this, our answer will be approximately 181 square meters. So show me the answer, then you round it off. Next part is part C. Calculate the length of BC. So BC is over here. How to find this side? Define the included angle, is it? Okay, so Ali is saying this over here is 180 degrees minus 60 degrees, and you get 120 degrees. So what's the use of this? Sine rule, is it? How? That one was the cosine rule. Okay, so Ali wants to use cosine rule. Can you form an equation for the cosine rule then? What is it? We will need another side to use our cosine rule, right? So what else can we use? Can we use our sine rule? Sine rule, right? Our sine rule says this: A over sine A equals to B over sine B equals to C over sine C. And then you must know what all these ABCs mean, what they represent. Okay? So, back to this one, this diagram. No, you don't have to write the formula. I'm just writing it to show you only. Okay? You don't need to write all this. Now, Ali, he did the correct step. He found out that this is actually 120 degrees. So, write it down in words. Angle DBC is equals to 180 degrees minus angle ABD, which is, and then the reason is adjacent angles on a straight line. Why do I need to find this? So that I can find this angle over here. Okay, and this will be 180 degrees minus 34 degrees minus 120 degrees. And the reason is because angle sum of triangle. Okay, so angle BDC equals to 180 degrees minus angle DBC minus angle BCD. That is 180 degrees minus 120 degrees minus 34 degrees. And the reason is angle sum of triangle. They add up to be 180 degrees. So this gives me 26 degrees. Okay, now summary. Yeah, you must write the reason. So here I have 120 degrees. This is 26 degrees. Okay, then how? How to apply my sine rule, Shermaine? I have all the information on my diagram already. Can you help me form the equation for sine rule? Come on, quickly start. We only have one period today. Can see now? over sine 34 degrees. Okay, good. She identified one side and its opposite angle. So yes, 19 over sine 34. What is this equals to? I want to find the yellow color line. So what do I do next? Over sine 26 degrees. Please get yourself familiarized with this formula. One side over sine angle, another side over sine opposite angle. We can form a third one, but we don't need it. Because now we have one equation with one unknown, and the unknown is BC. Okay, now we can solve for BC by what do I do on both sides? Times what? Times sine 26 degrees. That is sufficient. Right, if I multiply by sine 26 on both sides, I'm left with BC only. And this will be 19 sine 26 degrees divided by sine 34 degrees. Yes? Then find the answer, it will be something rounded off to 14.9 meters. Now, question, what's this question? Question 8a, giveaway question. Write a line of symmetry for PQRS. First, you need to identify the line of symmetry. And it looks like this. Right, this green line that I just drew. What is the equation of this line? Undefined. 4. So the equation of line is 4. Is this an equation? No, this is a number. We need y equals to 4 because everywhere on this line, y is equals to 4. It's not negative 4. It's just a. This is part of the square, you know. What is your question? Sorry. No, I'm asking you to write y equals to 4. Okay. So that is her question. Why is it that in our practice so far, right, our line of symmetry always resembles this. X equals to 3. X equals to -1, right? This is what we always see. Whether it's because in those questions, we usually ask about line of symmetry for a parabola. And the line of symmetry for a parabola is a vertical line. So in this case, this could be x equals to 3. Whereas for this case, what is this line of symmetry? It is horizontal. And the horizontal line is given by y equals to something. Okay? So let's look at this green line. On this green line, what are all the y values? They are all 4. All the y values are 4. That is why we call this line y equals to 4. What about this vertical line in this parabola? All the x coordinates are 3. That is why this line is called x equals to 3. Does that answer your question? Okay. So the line that I want in this question paper is y equals to 4. Part B, write down the coordinates of Q. Where is Q? 5, 7. I'm sure during exams, right, some of you still don't know how to read coordinates because you'll still be wondering, do I put 7, 5 or do I put 5, 7? When you think about this during the exams, it just proves that you haven't been studying enough, you haven't been practicing enough. Then you will need to kick yourself after the exam is over because it's so easy. Only one thing you remember, we look at the x coordinate first. So Q, this is actually 5, 7. Okay, Q, 5, 7. Part C, calculate the area of PQRS. PQRS. Okay, this blue figure, how to calculate the area? Okay, we cut it into 2 equal parts. Earlier on, we had our line of symmetry, right? So now I have 2 triangles, and they are the same triangle. They are congruent because it is divided by a line of symmetry. So how do I find the area of one triangle? Count the units you see in primary school. Because the 2 times the area of PQR. PQR meaning a triangle. Okay, so now how to find the area of PQR? It will be half times base times height, or half AB sine C. Which one do you want to use? Half times base times height because we can find the base and the perpendicular height very easily. So what is the base? 9. How do you get 9? 12 minus 3 to get 9, right? Or you can count. But if you don't want to count, if it is very difficult to count, then it will be 12 minus 3. This is the base. Then times the perpendicular height, 5 or 3. Okay, let's calculate. 7 minus 4. Okay, half times base times height. This is the area of one triangle. Then I need to multiply by 2, right? So then this gives me 9 times 3. 36 square units. Or you can write UNITS with a power 2. Okay? Did I make a mistake? 9 times 3. 9 times 3 is 27. 27, sorry. What, still have? Okay, now find the equation of line PQ. I don't need all this information. PQ is over here, one short line. But the equation of this line is actually the equation of one. You can actually extend this line, right? Okay? Now, to find the equation of line, we need to find the gradient and the y-intercept. Is this diagram drawn to scale? Did they say whether it's drawn to scale? No. So whatever I read off the y-intercept over here may not be accurate. Okay, so in order not to confuse ourselves, we don't draw it. Okay, now to find the gradient, I need two sets of coordinates. And over here we said that this is 5, 7. What are the coordinates over here? 3, 4. Now I can find the gradient, right? Equals to 7 minus 4 over 5 minus 3. So as you are calculating, look at this. Are you expecting a positive or negative gradient? How is it sloping? Up or down? Up. So we are expecting a positive gradient. So our answer should be positive. So 7 minus 4 is 3 divided by 2. Okay, this is a positive number. This is my gradient. Makes sense so far. Then the equation of a straight line is y equals to mx plus c. We already know the value of m. That is 3 over 2. Now I need to find out what c is. So what can I do? What should I do? Yes, substitute. Substitute what? I substitute coordinates. I substitute a pair of coordinates. A pair of coordinates has x and y coordinates. Now I have two coordinates to choose from. What to choose? Does it matter? Doesn't matter. All of them will satisfy it. So if I sub 3, 4 into equation number 1, let's just call this equation number 1, I will get 4 equals to 3 over 2 times 3 plus c. And therefore c is equals to, how much is it? 9 over 2, negative half, right? So now, sub this back into 1, I will get y equals to 3 over 2x minus half. In our algebra, we avoid using decimals. We try to leave everything in fractions. So what do you write? Y equals to 1.5x minus 0.5, is it? It's okay, but I recommend don't. Can? Who needs more time for this? Okay, so just now I said that we can choose to substitute 3, 4 into equation number 1. What happens if I were to substitute 5, 7 into equation number 1? Let's see. If I sub 5, 7, because that is also a point, right? 5, 7, also a point, into equation number 1. So 7 is equals to 3 over 2 times 5 plus c. And then now I try to find the value of c. I will realize that 7 is equals to 15 over 2 plus c. C equals to negative half again. So I will still get y equals to 3 over 2x minus half. They are the same. Whether you substitute 5, 7 or 3, 4 inside, because they all lie on the same line. Now calculate the length of RS. RS. So we need to use our formula for length of line segment. That is given by square root of y2 minus y1 square plus x2 minus x1 square. Have you all memorized this already? Yes. Really? Yeah? Yes. What if you forget? It's like gradient. I think what you meant was that you have your y1, y2, x1, x2, right? It is like something else actually. Okay, let's see. Yeah, it is like your Pythagoras theorem. Why do I say that? RS is over here. What are the coordinates here? 5, 1. And over here we have 12, 4. Okay? I want to find the length of this highlighted part. So I can actually draw a right angle triangle, right? And what is this side? What is this? This is 4 minus 1. Okay, comparing the y values, 4 minus 1. And over here I have, it is not drawn to scale, but I can still read off the coordinates. And here I have 12 minus 5, right? Then what should I do with them? Anissa, what should I do with this? I got a 4 minus 1, I got a 12 minus 5. Start? You are saying using this, is it? But if I don't want to use this, I will use Pythagoras, because somehow during the exams I forget about this equation. I forgot about this. I cannot use it. But I do see that this is a right angle triangle. So how do I find the length of the yellow line? Yeah, we use Pythagoras. So this is equals to, over here, this is equals to 3, while this is equals to 7. So 7 square plus 3 square equals to the yellow color side square, isn't it? Okay. Now, which part wrong? Which part? Oh, no. It was correct. I'm just saying that if you forget, then you cannot use it, right? Okay, so now let us use back our equation, our formula over here. The length is equals to y2 minus y1. y2 minus y1. So 4 minus 1. And we square it. Then we add it to x2 minus x1. So 12 minus 5. And we square it. Then we take square root. Okay, now, does this look very familiar? This one over here, as well as this one. Look familiar? Yes, right. Look at the red color one. Isn't it 4 minus 1? Red color. Then the gray color one, 12 minus 1. Isn't it the same? Same, right? You know why or not? That is because when we derive this equation, this formula for length, it is based on Pythagoras theorem. That is why they are so similar. So if I were to use Pythagoras to solve it, I will take 3 square plus 7 square, right? Is there? Here, 3 square plus 7 square equals to the yellow color side square. And I'll take square root. There, it's over here. For the yellow color line. Okay? And our answer will be something and approximate it to be, this is square root of 58, approximately 7.6 dp units, because the question wanted it to be in 1 dp. Can? Question 9. These two triangles, they are congruent. Congruent means they are exactly the same now. Okay? And for congruency and similarity triangles, questions, always draw the triangles out yourself. So for example, in this case, they say that ABC is congruent to DEF. So I'll draw ABC. ABC. I try to draw it as closely as I can to the diagram. So this is X, this is 42 degrees, and this is 5. It is congruent to another triangle, right? What is it called? DEF. Now, should I draw it upside down? No, I shouldn't. Because if I draw it upside down, then there's no point. I'm just copying the same thing. I draw it exactly the same way. One long base, one small angle, and then another side. They look quite the same. Okay, try to make them as similar as you can. So this triangle is ABC, congruent to DEF. So we go the same way. ABC, DEF. So D must be here, E must be here, and F must be here. Without looking at the diagram, without looking at this, I drew this myself. Okay, that is based on the question. A, B, C, D, E, F. Orientation is the same. Which is why we say that it is very important how you label your triangles. There is an order to it. And now I'm going to fill in the blanks. What is DF? Okay, DF is 8 cm. Then DE is Y. DE is Y. What else do I have? 104 degrees is DEF. DEF. This is 104 degrees. And finally, there is an angle Z over here, which is DFE. DFE. This is angle Z. And they want me to find the values of X, Y, and Z. Isn't it very easy? We can just compare, right? How much is X? How much is X? According to the diagram, 8 log. 8 cm. What about, okay, I don't need to write cm. What about Y? How much is Y? Yeah, 5 no, we shouldn't write cm because in a question, right, they said X cm. So if you say X is 8 cm, then it becomes 8 cm. Okay, now Z. How much is Z? Z is over here. How to find? Yeah, we are supposed to use the angle sum of triangle. So over here, what is this angle? 42 degrees. Then I can find Z already, ma? Alright, this is 180 degrees minus 42 degrees minus 104 degrees. Reason, angle sum of triangle. And the answer is 34 degrees. Where? Okay, yeah, for the same reason, we don't write degrees. It is 34. And that's all the time we have. What do you thought?